So this next example recycles the matrix that we have seen before and tells us already that the determinant of this matrix is 57. And now we need to find the determinant of these matrices that look kind of similar to the original matrix. So let's see. The first one for part A, well, how are they different? The only difference that I see is the second row here. And the new second row is actually just the old second row multiplied by 2. So 3 times 2 is 6, negative 5 times 2 is negative 10, and so on. So when that happens, whenever I multiply a constant to every entry in a row or a column of a matrix, the effect of that on the determinant is that the determinant is going to be multiplied by the same constant. In this case, that's a 2. So the determinant of this guy is going to be 2 times 57, which is 114. Now for part B, so what are the difference? The difference, let me see. The last row is different. Well, how do I get the last row from this guy? Well, in fact, the new last row is actually just I multiply 5 to the old first row and I add that to the last row. So if I multiply 5 to 1, I get 5, add that to by 12, so I get 17. 5 times 2 is 10, 10 minus 5 is 5, 5 times 1 is 1, I add that to 1, I get a 6, 5 times 0 is 0, and I add that to 1, so I get 1. So the new matrix is the old matrix where I add the 5 times row 1 to the last row. So this is the standard row operation, and when we do this, whenever I multiply a row by a constant number and add that to another row, the determinant of that matrix will actually remain the same. So the determinant of this guy will still be 57. Okay, how about the next one? The next one, what are the difference? Well, this guy, if I swap the first row and the third row, I will get the original matrix. So this guy is just the original matrix with the first row and the third row interchange. And when I do that, the determinant will actually flip the sign. So the determinant of this guy is going to be negative 57. So these three things are the effects of the standard row operation on the determinant of the matrix. Now let's move on to part D. What did I do? For part D, the third column is different. Where does this number come from? Well, this guy results from subtracting the first column from the third column. So if I subtract 1 from 1, I get a 0. If I subtract 3 from 1, I get negative 2. I subtract 0 from 2, I get 2. I subtract 12 from 1, so I get negative 11. So it's the same thing that happened in part B here. So same old. If I add a multiple of a column to another column, then the determinant of the resulting matrix will still be the same. So this guy will still have determinant 57. Okay, and now we are on the last one. The last one, what did I do? The last one, this is actually the transpose of the old matrix. If I transpose the old matrix, so I change the row into a column, I change a row into a column, and I change a column into a row. When I transpose a matrix, the determinant will remain unchanged, so the determinant of this guy will still be 57. So these are how the standard operations on the matrix affect the determinant.